Hello, my name is Lee Canning and I'm a network and cybersecurity student at the University of Wales, Trinity St David. This is my presentation for coursework 2 for the Network Operating Systems and Services module. The aims and objectives of this presentation are to showcase the fundamental knowledge of concepts of routing protocols. We also have a case study which analyzes protocols used in network scenarios in the university campus, and it reflects on the benefits and drawbacks of each of them. We will then summarize key concepts, features and best practices of network services such as virtual private networks, dynamic host configuration protocols, Active Directory domain services, and certificate authorities. So first we're going to look at routing protocols and how they work. Routers are networking devices that forward packets between networks. Routing is the process of selecting the optimal path for the data to travel, and the routing protocol are a set of rules that specify how packets or data are forwarded. So within dynamic routing, we have two main protocols. We've got the interior gateway protocol. This exchanges routing information within an autonomous system. And then we have the EGP or exterior gateway protocol. This exchanges the information between gateways of various autonomous systems. Within IGP, we have the distance vector protocols such as RIP and IGRP. These basically decide the best routes based on distance, and they measure that by how many routers packets travel through, known as hops. RIP broadcasts updates of its routing table periodically. This can be problematic in large networks because when it broadcasts the routing table, there's a burst of information, and also it has a maximum of 15 hops, which limits its usefulness in large networks. IGRP overcomes the limitations of RIP, the interior gateway routing protocol. It has a maximum hop count of 255, so much better. And it also takes into consideration bandwidth, load, and reliability. Then we have the link state protocols. So OSPF is open shortest path first. The aim here is to take the shortest route to the destination. It establishes relationships with its neighboring routers to exchange the network topology, and then runs the SPF, which is the shortest path first algorithm, to calculate and add the shortest routes to its routing table. After that, we have hybrid. So the enhanced internal gateway routing protocol is a Cisco protocol essentially, but it aims to combine the best of distance and link state routing, the best balance between speed, scalability, and the ease of management, and it's broadly considered the best, but again it is kind of limited to Cisco architecture or infrastructure. Now we're going to look at static versus dynamic routing. So with static routing, there is no protocol. It's manually configured. As you can see, the example here of a routing table, the administrator basically needs to update it and tell it where the next hops or next routers are and the route that it should take. It needs to be updated whenever network changes occur, and it's better for smaller networks and simple topologies because of this. When you start looking at larger networks, the table's larger, there's more changes or updates that need to be made every time there's a change in the network. Okay. It's secure because it doesn't share its routes over the network, and because the routes are already defined, static routing can provide lower bandwidth and CPU usage. Now with dynamic routing, it uses the protocols we mentioned on the previous slide, like OSPF, IGRP, to send the data down the optimum route. It's automatic and is self-configured, and it can adapt to network changes. So if routers or switches are taken away or added, or if there's a failure, they'll take those into account when making the next set of calculations. So these are far better for larger, more complex networks like enterprises, those with multiple networks in different areas or locations. They can be less secure though, because the routers advertise their best paths and information frequently, and these can be intercepted. Also, because of the calculations made and the broadcast status, they can require more from the CPU and from the bandwidth. So this needs to be taken into consideration as well. Now onto our case study about a university campus. The campus is increasing its IT department, constructing a new building to house it. And this means there's going to be an increase in students and IT equipment and devices. So they're currently using the RIP protocol, but they've experienced slow convergence times and routing loops in the past, especially during failures and periods of maintenance. So this has affected the speed and the reliability of the network, so they're reviewing it ahead of the expansion. The challenges here for the university to avoid routing loops and slow convergence, scalability, because more users equals more devices, and they need to plan for future expansion too. RIP has limited scalability due to its hop count limitation, and this would become even more problematic with a larger network because it focuses solely on hop counts, not bandwidth or congestion. It doesn't take these into account at all. It's slow to update its routing tables when network changes or failures occur. And again, this leads to routing loops and occasionally black holes. So OSPF is more complex to set up, but it overcomes a lot of RIP's deficiencies. First of all, it has faster convergence. It takes bandwidth congestion into consideration to calculate the best paths after changes or failures occur. Provides loop-free routing. It can be deployed with future expansion in mind because it can be done with minimal configuration. So considering all of the above, the university have basically decided to implement OSPF during the expansion so that they can improve the performance and the reliability of their network, and then they can future-proof it should they need to expand again. VPN, or Virtual Private Network. Now the key concepts behind this is that a VPN is a logical connection for transmitting data securely. It carries private network data over a public network, and it can be secured via tunneling and encryption. So tunneling is essentially a private passage that connects between VPN gateways or a client and the VPN server. The data inside is hidden. It can provide confidentiality because the IP address is hidden, and it can provide security because the data is protected using encryption and authentication protocols such as ACCA5023. Privacy is maintained because only authorized users can access the data. Scalability is a feature because remote access VPNs allow many users to log in securely from anywhere. It can provide granular access control, so only designated users can access network resources, and the organization can define who can access what. The best practices here are protocols like ACCA5023 IPsec or OpenVPN offer far more reliable security. You need to ensure that the VPN uses strong encryption algorithms and authentication protocols like AES-256. This basically ensures that the data is scrambled even if it's intercepted by a third party. And finally, MFA. It adds a layer of security because users have to provide two forms of security such as or authentication such as a password and a passcode separately. So we're going to compare remote access to site-to-site VPN. So with remote access, it connects to an organization's network when off-site via a login to a VPN server. So it is often done via a web browser or can be done via a desktop client as well, such as Cisco AnyConnect. Uses secure socket layer or transport layer security to encrypt the data transfer, and is utilized within SSTP, which is Secure Socket Tunneling Protocol. You can see here an example of remote access. You've got the VPN clients here, connect via the browsers, through the tunnels, via the gateway, then to the VPN server within the organization. For site-to-site, we're looking at larger multi-site organizations that want to connect separate networks via the internet. The gateways provide them with secure connectivity between these multiple sites. For example, an organisation with, say, an office in Cardiff, say Office 1 here, and an office in London, Office 2 here. Each has their own network, and the VPN allows these networks to connect via the public internet through an encrypted tunnel or a secure tunnel, and then users can access shared resources. Some of the site-to-site protocols, such as IPsec, these offer robust security features like encryption and authentication for data packets. IPsec operates at the network layer of the OSI model. It can provide confidentiality, integrity, and origin authentication. OpenVPN, that is open source and customizable, so it's a very good alternative to IPsec. And IKE version 2, it's not a core tunneling protocol as such, but it often works alongside IPsec to simplify the process of establishing secure connections and managing encryption keys. DHCP, Dynamic Host Configuration Protocol. So assigning IP addresses can be done statically or manually. This includes a subnet mask and the default gateway. So it's ideal for small networks, but as the pool of addresses increases, this becomes time-consuming and error-prone, and the list holding these addresses needs to be accurately maintained to avoid conflicts. So DHCP automates this. Administrators define a pool or a scope of IP addresses, and the DHCP server leases these addresses to clients, usually from 24 hours or more. So when the lease expires, the client reapplies. If a client is no longer required, the IP is reallocated and addresses can be reversed so that certain clients retain the address, and that's useful for printers and servers, etc. It frees up time and resources, as administrators do not need to configure every client's address. You can imagine this in a large-scale organization with thousands of clients, and it means they don't need to worry about any IP conflict issues. So the processes and best practices for DHCP are as follows. First of all, the client offers a discover message to the network. The server replies with an offer, basically saying that they do have an address available. The client then requests that address, and the server acknowledges that request. And the client can also release an IP address once it's finished with it. The best practices here are to create separate scopes for each subnet, improves organization and simplifies management, set appropriate lease time, so longer for servers or permanent for servers, much shorter for mobile devices. Consider reservations, so critical and static devices like printers or servers should have a dedicated address. Being unique, a domain controller should be on a separate server for better performance and security, and then plan for redundancy with failover and security. So set up multiple DHCP servers in case the primary server fails. ADDS, or Active Directory Domain Services. So directory is basically a hierarchical structure that stores information about objects on the network. A directory service, such as ADDS, provides the methods for storing the directory data and making this data available to network users and admin. So you can centrally control users. This verifies the user's identity and determines access rights to resources and devices. Users can access shared files or resources from the server. It has group policy management. So this is where admin configure security settings, resource access, and software configurations based on group membership. So for example, a Band 7 lead software developer would have different access levels to a Band 4 administrator. So ADCS, so Active Directory Certificate Services, is a Windows Server role that issues and manages PKI, or Public Key Infrastructure certificates. Digital certificates are issued to authenticate the user or device accounts and to encrypt them. So security is enhanced by connecting an identification to PKI. So this info from Active Directory can be automatically inserted to these certificates. and group policies can then be utilized to allocate the certificates to users and devices using the role-based or attribute-based control. It features web enrollment. This is when users can connect to the CS or CA via a web browser to request the certificates. The TPM, the Trusted Platform Module, the CA verifies that the PKI is protected by a Trusted Platform Module, and it is one that the CA trusts and prevents the certificate from being exported to another device. And the best practice here is to store the private key securely and to designate root certificate authorities. And here we have the references I used for this presentation. Thank you for listening. I hope you enjoyed it.